Okay, guys, so welcome to the fourth session of the Swift Primer, which is the last class we're going to have in order to start developing apps for iOS. The agenda for today will be how to handle errors, how to create error types, protocol delegation, closure blocks and threads, and concurrency. So let's dive into it very quick so that we have enough time. Okay, so let's start with error handling. So week, last class, actually, we started using a little bit of that based on one question. Let's look for that. We have some error around. Yeah, exactly. So we created a custom error here with a case. So basically, errors here are as easy as creating cases of an enumeration that inherits from the error type. And what we do with this error type is literally just throw it, just because we have an operation that is meant to potentially fail if something unexpected happens. So in this case, we have a guard. Uh, Last class, we talked about the guard, which is like basically a security class that will allow you to guarantee that certain condition is met before continuing with the positive flow of the operation. So in this case, the positive flow is promoting an employee. We continue on the same line to promote the employee that actually exists, but first we need to guarantee that the employee is actually found in our original list. So in this case, we use a closure to say, okay, when this ID is met, find an employee. If it doesn't meet any of the employees in the list, that means this is not going to succeed, hence it's going to throw the error that we mentioned. So this is the way we throw errors. Of course, when it comes to handling errors, there are many things we can do with them. We can either throw them, we can handle them, and there are actually also ways to say, okay, if we have an employee and we need to find it, let's try, but if it doesn't succeed, let's make it nil. So let's actually create an operation for that. We can create an operation to say, okay, find employee with ID, this takes an ID of type UUID, which is a type we discussed. That's that. And then this is going to return an employee. So we can say this is optional because we don't know if this function is actually going to find the employee meeting this ID. So what we can do is just use this. And that's it. But then what if we want this to throw an error if it doesn't exist? We can just say, okay, we need to guarantee these returns a non-nil employee. And then we need to say, okay, this needs to throw an error if it doesn't find any employee. So in this case, we say, we have a guard let that is the first one that meets this criteria. And if it doesn't find the employee, it will just return this error. Not return, but throw. And then we will just return the promised employee. But then whoever uses this function will need to take the responsibility of handling this error because this is a throwing function now. So very similar to what we had before, where this was returning an optional employee, what we can do is, okay, our employee is potentially an optional employee that is going to try to find an employee with the ID. So it's going to use a function find. Isn't this completing? Am I in a different context? No, I'm not. Okay, yeah, sometimes this is not enough. So it's not enough. Okay, with ID, we pass the original ID we are looking for, and then we have this exact same thing that we are doing this here. So basically, we're saying, okay, try to find the employee. If it doesn't find it, if it throws an error because it doesn't find it, just like return nil, and nil is the value that will be allocated if this doesn't succeed. So basically, this is a way you can handle errors. So if you don't want to handle errors per se, and you just want to resolve a nil if this throws an error, just use this class, and that's it. You can also use this and make it crash if it doesn't succeed, because you're expecting to always succeed. But again, this sign is actually never recommended unless you have a very strong opinion on how to use it properly. And maybe your code is set enough so that to guarantee that this will never crash. But of course, that's rare to find. But then, okay, this is actually a way you can also handle errors, where just literally disregarding completely the error that is being thrown here and resolving them. Okay, another thing you can do is use the do catch clause, which is actually very similar to what you guys may be familiar with for the try catch on other languages like Java, C#, JavaScript. And basically, the do catch will allow you to say, okay, we need an employee. And this is going to try find the employee. So it's basically this instruction here. And we're just counting with the fact that this is going to find it, because otherwise it's going just to throw an error and it's going to fall on this class, on the catch. So basically we can just take or like that there and print the error if something was caught. And that's it. This is the way we actually do try catch. The try is actually for saying exactly what instruction may throw an error. And the do catch is the one that, the do is where you will put the positive flow, and the catch is where you will handle the errors per se. So that's the way you handle errors here. Do try catch. You can also use the optionality. And of course, you can always say, okay, this is potentially going to throw, so you may not want to catch this here because it's a throwing function. So in this case, this is not even necessary because we are actually saying the function may throw. That means whoever uses this function will need to do the error handling. So this is actually very similar to other languages, not too new for you guys. But yeah. This is it for error handling. So great thing about this is the fact that you can capture errors of like operations that may be running for APIs or storage or whatever third-party operations you may be running. But you can also create your first-party errors with enums. Just by inheriting error and creating cases, you can go ahead and throw as many error cases as you may find fit for your use cases, and of course for your environmental conditions for your application. So this is it for error handling and error types. It's actually fairly simple to handle and manage errors in Swift. It's one of the great things about this language. And yeah, just is there any questions about error handling before we jump on another topic? Nope. Awesome. Okay, so we're gonna leave this like this because this is a throwing error, which means it's fine if it throws an error. Same here, it's trying if it throws, the function is throwing. So let's leave it like that. Then we're going to talk about, we already talked about enumerations for types. We talked about structs. We talked about classes, and we even saw how to create errors with enumerations here. But what about what you call in other languages interfaces? Do we have the option to create an interface? Yes, we do. And actually, they're called protocols. They're basically the same thing. They're simply an interface that will say that certain type is going to allow something to happen, and it's going to make certain types compliant to a set of signatures. So let's actually create a protocol for this class. We're going to say we have a protocol called employee coordinator protocol. And basically, all this does is, okay, we're going to say whatever is actually an employee coordinator protocol is going to implement a function that is called find employee that may throw and return an employee. And of course, we can make it implement this protocol here by saying colon employee coordinator protocol. Did I type it correctly? I think so, yeah. Okay, so basically this is compliant because of course we have the function. If we remove it, this is going to fail eventually once Xcode responds, because we're not compliant to the protocol we're implementing here. Yeah, for some reason Xcode is not responding. Have some patience. Under the impression this will not work unless I make it run. Actually, we still have an error from last session here. That's because we created something called start date, but we're not providing one. So let's add the start date very quick. Just today's date, doesn't matter. And now we're saying, okay, this employee coordinator doesn't conform to protocol because it's not compliant. And basically it will prompt us to create a protocol stops, which will create a function for us. This is a little bit nice, but it won't put it in the right position. So we should put whatever we see. Okay. So basically, this is what protocols do. It allows us to comply to a signature that we create. We can say this is actually meant to have an array of employees. That is an array of employees, and it should be ready for get and set. Or maybe for the sake of creating a proper interface that is safe enough, we are going to say, okay, we require this to be get. Just read only, that means. And this is failing because, of course, we didn't say the right name. Okay. Okay, so basically we're complying to this because we have a variable here that is actually gettable and settable. Hence, we are complying to this get stop here. But we say set would also succeed because this is also settable. If we want to make it safe enough so that whoever implements this coordinator doesn't access employees for writing purposes, what we can do is make this get only, and we're going to create a private employees array. And basically, this employee property will be a computed property that will literally just return the value of the inner employees property. In that way, we can use the internal employees here for writing purposes, for private internal purposes. In that way, we are only exposing the ability to read the employees list, but not to actually edit the employees list. So this is something you can actually do on many other languages. You can do it with protocols here by having different flavors of it that will have the option to read employees, but depending on your specific implementation, it will give you the option to constrain the user not to modify the inner content of your array or whatever property you're setting. Okay, so let's talk about a little bit about delegation. So delegation is one of the most important uses of protocols, and basically will give you the option to create a communication back and forth between different types. So let's talk a little bit about, this is still not compiling, let's fix this. Years in company is actually a computer property, so it shouldn't be stored here. Okay. Move this. right? Let's make sure this runs. On employee is a let constant, of course, that makes sense. It should be a variable. Okay, and this is running again. Okay. So going back to delegation. So delegation is actually a way to create a communication between two types. So let's say we have an employee coordinator here, and we want the employees' instances to have access to the employee coordinator in order to be able to do something with it. So let's say we want to delete an employee and say, okay, we want to create a function here that is going to delete this. But this actually can't delete itself. This would be just for convenience sake. In order to delete this employee, we need access to the original list where the employees are being held. And that way, looking for the employee and deleting it from there. So the only option we have here to be able to delete the employee is to have access to the original list, which means since the employee coordinator has access to the employees, we need to pass a reference to this coordinator in order to be able to delete the employee. So let's say we have a function here that actually runs the operation of deleting the employee. And basically what we'll do is, okay, use the list and remove, there's one for, okay, we can use this remove all whenever this is met. This is one option, but we want actually to remove a single one. So there was one for that actually. Remove all index, not the one we need. Okay, we can look for the index here.
There's a remove where.
Yeah, but I guess I want to look for the exact reference of that. Yeah, I guess I could also do that. We could use, yeah, the remove where. But basically, in this case, we need to say, we need to have an option to determine whether the employee is the exact same one we're looking for. Fortunately, we have the ID, so what we can do is remove all the instances where the employee, the one we are iterating over, is equal to the employee.id. And this will do the job for us. So the coordinator already has access to the functionality of deleting, but if we want to provide the delete right from the employee, we want the employee to have access to that coordinator. So in this case, there's a relationship between the coordinator and the employee, because the coordinator has a list of employees, but then the employee doesn't have a way to communicate back to the coordinator. And in order for that to happen, we need to create some kind of delegation. So what we can do is create a protocol that say, okay, this is an employee, employee remover, and any employee remover will have to have an option to delete an employee. So that means the employee coordinator can already implement that protocol, employee remover. And that means we can have the employee take a remover, which is an employee remover. And that should be optional because it may not have it. So in this case, we can just call the remover and say delete and say set, because we are trying to remove self right from there. So this is optional, of course, because at the moment of creation, we are not passing any of the, at the moment of creation, we're not passing any remover. And that's totally fine because actually this is going to have a keyword, an additional keyword called quick. What does quick mean? Quick means there is a soft, a weak reference back to whatever we are setting here. So the reason why we need to make this weak is because we want this connection to be strong, but this connection to be weak. This is a weak connection. And what does that mean? That means basically if there is not strong connection between them, these will be completely disregarded. Meaning if this coordinator stops existing, that's totally fine. The reference on employee will stop existing, and basically this will be nil. Okay, another thing is the reason why we can't do this, and the reason why this is actually failing here is because this is struct. So in this case, should potentially be a class, because we're talking about connecting references between classes, because those are the only ones that actually behave like references in memory. So this is actually important when dealing with classes. This is assuming an employee and the coordinator is a class. But in this case, of course, this is a bad example because we don't want to ever delete right from the same instance, the instance from the list. So this should not be the case, but if we have these be classes or have a different instance that we want to rely on and create a cross reference between them, basically this will be the perfect way to do this. In this case, for the sake of the class, let's make this class real quick. This will take, of course, manual initializer to create here. 90 here. We can use the this initializer here. Position, this is a boolean, and basically this will initialize everything. Right, so here we have it. Okay, another thing we are having here as an issue is the fact that employee remover, we're not considering it to be a class-only protocol. So in order for that to happen, we need to say, okay, this will apply only if the employee remover is any object, meaning this is actually based on a class and not a struct. It's important for it to know, otherwise it won't be able to tell whether this week is valid for that remover, because we don't know exactly what is implemented that employee remover and what we are going to assign here. So with when we create a protocol remover, we're saying, okay, this only applies for classes. So that means employee remover can only be implemented by another class. So that's it, we already have it. Okay, mutating is not by instance. Okay, because mutating is not meant for classes, but only for structs, as we discussed last class. And that's it. So we have it. We have a connection between a coordinator and employee, which is strong connection. Why? Because under a coordinator, we actually have a regular variable of an array of employees. And whenever we don't specify whether it's weak or strong, it's going to be strong by default. So in this case, in order for avoid circular references and having issues with memory, we're going to have this connection be weak, and this has to be weak here. Okay, so in order for this to start happening and for this to work, we need to pass a reference of the remover. Where is it? Yeah, the remover to the employees. So whenever we create this array initially, in this case, when this is being passed, what we can do is iterate over them and say we're going to map them. and have them be the exact same thing. You can say, okay, this is a employee copy. And then we modify it. Employee copy dot remover equals self. And we can just return the employee copy. And that way we are mapping all the employees to have whatever we need. Okay, this is bad because it's for an operator, so we're not actually injecting it here. This is going to take the first parameter, so we don't specify it here. Otherwise, we can take the parameter here and say employee, original employee, and then replace it here. Another option. Okay. So here we have it. Whenever we create this employee coordinator, this is going to initialize with an array of employees, and it will have we will go over them, map them, and have them the reference of self, because self is a remover, hence it has the ability to remove, and we're going to pass it as a wiki reference to the original employee copy, and then return the employee copy. And then all the employees that we have will have the ability to delete themselves, which is a little bit strange, but for the sake of this class, this works because this will allow us to have a way to have a communication between two instances. And actually, this will be more clear whenever we start seeing a little bit of UIT in the next classes, because UIT relies heavily on delegation. And basically what we're doing here is actually creating a delegate. The remover is a delegate that handles the responsibility of removing something. So let's talk about another example of delegation real quick. And I think that will be the last instance for that class, for this class. Let's say we have an operation, a long-running operation. So we are going to say fetch employees. And we will need to run a long-running operation to fetch all the employees. So it's actually fairly common, and despite it's not the most common use case, what you can do here is say you have something that is actually responsible for fetching the employees. Say you have a class, it's called employee fetcher, and then this has a function that does the job. Let's say it's just called run, just like that. And this actually runs the operation. We can say we have an instance of that employee fetcher here. We say we take it so that we rely on dependency injection. This takes an employee fetcher. This is going to have a private fetcher. And we're going to initialize it here. So that means we can actually run the operation here and say, this fetcher run the operation. But then what happens whenever the fetcher brings back the employees? Like, I mean, we are not providing an option to bring this back to our original array where we want to allocate our employees. So we can actually say the fetcher will have a delegate that can use to deliver back the employees back to us. So we're going to have something called protocol called employee provider. And this will basically take a function that says, okay, deliver employees. And it will take the employees that were brought by the response to this operation. And then we're going to say this employee coordinator is also an employee provider. Which means the employee fetcher should have something called a delegate that is a weak delegate, of course, It's an employee provider. And this is optional because it's weak. Like whatever you mark with weak will always be optional. So in this case, this is failing because of the same issue we had before. This should implement any object, not to say this should be a class always. And then this is failing because we are not complying to the employee provider. So we're going to implement the function and say deliver. And what we do with employees is just inject them to our array of employees. Append function soft, and then employees. Of course, this is for appending, which is also replace, but for this case, let's keep it as appending. Okay. And then what we do is whenever we create a fetcher, we're going to say the fetcher has a delegate called set. And that's it. So we already have a fetcher that has a way to deliver back the employees that is able to bring from the server or whatever instance. And basically, it will use it to deliver the employees that it brings. So let's say this is going to bring a few employees. Okay, let's see what names we have here in the class. We have Roberto. We have Andres. We have David. And let's use this tree for now. This is separated by commas, of course. Let's pass this data around. You guys are all developers. I think so. Tell me if I'm wrong. And contractors or not, I don't know. Let's say true, false, true. Okay, so we are going to use this delegate to deliver the employees back. Of course, we're assuming we're running an operation here. We're going to talk about that later, possibly on the later class. And yeah, this is the way we actually handle the cross-reference between them. So this is what we have right now. We have a coordinator that has a fetcher, has a strong reference, but then we also have communication back to the delegate. Of course, this is a word reference. This is actually a better example because employee fetcher is meant to be a class, and that way we have a cross-reference between classes. In this case, employee was actually not meant to have, was not meant to be a class. It's actually more for structs. So we're not actually looking for deleting that. Deleting should actually happen from the coordinator. So let's remove this. It doesn't make too much sense. And this is muted. So basically what's happening with the fetcher here. So we are creating a reference to the fetcher. We have an operation that is called fetch employees. We are using the fetcher to run the operation. And whenever the run operation finishes, it will deliver back to us, the delegate, all the employees that it was able to resolve. And this is because there is bidirectional communication between them. But of course, it's a safe bidirectional communication by using this keyword called quick. And this that's the way we are avoiding memory leaks, because we are making sure that memory data is actually being discarded whenever there is not any other instance pointing to them. And that happens all because of the system called ARC, called automatic reference counting, which is very similar but slightly different to what we know in our languages as garbage collection. And this actually happens more automatically, which is the reason why it's actually called automatic. And that's the way they branded it many years ago, even before Swift existed, actually. And yeah, that's it for now. I wanted to cover more topics, but this is actually going to be a separate and more complex thing. So let's discuss it on a later class. For now, I want to open up for questions and comments about what we discussed today, and yeah, everything about these topics.
Yeah, I want to see a little bit more about those delegates.
Sure.
is that delegate right now it's enforcing at the class definition level that that class must have the coordinator. So if you remove coordinator, then the class itself will detect that it has to have that weak that the class itself when you define the class, you no a little bit lower down, lower please.
Sure.
Their employee coordinator. If you remove the provider, then what happens to the class definition there?
Yeah, the class definition per se won't have a problem, except for the fact that whenever we are setting self as a delegate, we say, okay, this is actually wrong because the fetcher is expecting a delegate of type, what is it? I lost it.
I got it. It's not automatic. You have to define a delegate as a weak, that you have to define the weak reference yourself.
Yeah, exactly.
Okay, got it.
And self has to be an employee provider, so it doesn't.
I thought that it was some sort of wiki of some sort of compiler level dependency injection.
Yeah, we are creating the bidirectional communication here. We have the coordinator has the fetcher, and the fetcher has the coordinator here. Yeah, but it's actually not expecting a coordinator. It's expecting anything that can handle receiving employees, which is the reason why we determined we need a protocol here for the employee provider. So it could be anything. It could be even another instance. It doesn't have to be the coordinator per se. But in this case, we want the coordinator to be the provider because we want to be able to inject the employees back to this list. Yeah, that's it. This is actually failing. Let's see why this is failing. Employee has no member. Oh, yeah, because we removed that. So yeah, any other questions, guys? Nope. Awesome. So yeah, I hope you like the class. Yeah, protocols are very similar to interfaces. This is what we focused on today, more types and delegation. Yeah, next time let's talk about closures and threading and concurrency, which is something super exciting because our apps are not meant to be synchronous; they're meant to be asynchronous. And next class we're going to start learning how to handle those operations that are asynchronous. Yep. So thank you so much. That's it for now. Okay, I will stop recording now. Take care.